All right, the next type of symmetry we have is called rotation. We're no longer thinking about folding along a line like we did in reflection. Now we're thinking about rotating around that central point of symmetry here, denoted as A, right? So an example of this is you take a shape, you rotate it about that central point once, and you get what we call two-fold symmetry, right? A rotation once creates two identical parts, two-fold symmetry. Now this can happen a number of times, right? Here's an example of four-fold symmetry. You start with one shape, you rotate it again to get two-fold, again threefold, again fourfold, until you have that final shape. So this square, you could say, has four-fold symmetry. Now two-fold symmetry, four-fold symmetry, those are pretty common. However, 5, 7, and 8-fold rotational symmetry don't appear in nature because the external shape of the crystal is based on the geometric arrangement of atoms, and these geometries just don't work with the internal atoms. They can't physically make a solid, right? Because there's a lot of gaps between these shapes. So 1, 2, 3, 4 super common rotational symmetries. 5, 7, 8, you're not going to see in nature. All right, knowing that, I want you to look at these shapes and determine what fold rotation do these shapes have. Right, looking at that first one, that first shape kind of looks like a triangle with its corners cut off. Right, so that one has threefold symmetry. Right, you could imagine a part of that shape being rotated 3 times. And then that second one has sixfold. Right, so you could imagine taking a triangle, rotating it 6 times to get that sixfold rotational symmetry.